All right, we're going to start in on the lesson 6. That is on page 25. And we're going to talk about signs and terms. Okay, so we're still using the area model and going into algebra, but we're going to go in just a little bit more detail, and we're going to focus on the signs and the terms. So I'll share my document camera with you, and we're on page 25. Okay, so all right, so important stuff here. So area model here, we've got 5 times y and -9, or y minus 9. So 5 times y is 5y, and 5 times -9 is -45. So then we have 5y minus 45. Okay, that's kind of a review from before. Here we have -j 3k plus 4, okay, right here. So we have -j times 3k, so that's -3jk, or you could put kj, it doesn't matter. And then -j times 4 is -4j. So you have -3jk minus 4j. All right. So here, just make sure a negative times a positive is still that negative. So think out loud dialogue here. So they draw a 2x2 model and write -b plus 3. Okay, it looks like they're multiplying this right here. Okay, how do we write the x minus 2 in the model? We don't write plus signs in the area model. So how do we write the minus sign? They say if it were addition, we'd write x and 2 on the other side. And so they write x and 2. I think of subtraction as adding opposites. So subtracting 2 is like adding -2. Oh, so we write -2 instead of 2. And we still multiply to find the pieces in the area. And then we add them together to get the product, which is exactly correct. Okay. These are operations, but they are also signs of that number. Okay, so we would put the -2 there, which we've seen before a little bit in prior lessons. So we have x times -b, that's -bx. -b times -2 is a positive 2b. And x times 3 is 3x. And -2 times 3 is -6. Again, kind of look here, we don't have anything matching. So we'd have -bx plus 2b plus 3x minus 6. Okay, and before we got negatives in here, and we would write them as a minus down here. So it's no different in that sense. Draw an area model and use it to multiply. Okay, so we got 4d and -7. So 4 times d is 4d, and 4 times 7 is -28. So here you have 4d minus 28. Okay, they put our negative m here. Here we have d minus 7 again. Okay, -m times d is -dm. I always just put mine in alphabetical order, or try to at least. It doesn't matter which order you put these in. So -m times 7 is 7m, because a negative times a negative is a positive. So you have -dm plus 7m. And we could write this another way. We could say 7m minus dm. Okay, you could say that. Sometimes we like these first initial terms to be positive. So that's the case, you would want that. Here we have -3 n minus 5. So here we've got negative 3n, and negative 3 times negative 5 is 15. What is negative 3n plus 15? Okay, here we've got two terms. So we're going to take 4 minus m and d minus 7. So just kind of finish this out here. D times 4 is 4d, and 4 times negative 7 is negative 28. D times negative m is negative dm, and negative 7 times negative m is 7m. Okay. So again, you can write these in any order. They start with the d, so I'm going to say minus dm plus 7m minus 28. I like to have my single number at the very end. That's known as your constant term, and we'd like to put those at the very end. Again, it doesn't matter though, okay? How do you draw the model? How you draw the model depends on the number of terms in each factor. So here we have one term and then three terms. We got three terms there. Okay, so it'd be a 1 by 3. Or I could draw the negative 3 up here and put three terms down. It doesn't matter. So negative 3 times 2k is negative 6k. Negative 3 times n, negative 3n. Negative 3 times negative 15, or negative 5 is positive 15. Sorry about that. Okay, I'll just go ahead and put a plus there. So here we have negative 6k minus 3n plus 15. And for the last ones on this page, they don't really give us anything. Okay, so we get to design our own area model. So I'm going to take negative 4 here. And I got three terms here. So 4r, negative 6s, and negative 8. So I have negative 4 times 4r, that's 16r. I have negative 4 times negative 6s. Okay, so a negative and a negative, that's a positive. 4 times 6 is 24, and then I have the s. And then negative times a negative is a positive. 8 times 4 is 32. Okay, so here we have 16r plus 24s plus 32. Here we've got two terms and two terms. So there's a possibility of four terms here. So n minus 5, negative 7, and d. And you could switch those spots. It doesn't matter which order or which side they go on. So negative 7 times n is negative 7n. Negative 7 times negative 5 is a positive 35. D times n is nd, or dn if you go alphabetical. D times negative 5 is negative 5d. Okay, so again, it doesn't matter the order that you're writing these in. So I could go dn minus 7n minus 5d plus 35. The order of these terms does not matter. I like to put all my letter stuff up front and my number stuff towards the end. Okay. Later on, this will be called a standard form. Okay. So going on to page 26 here. Terms. It says terms are parts. Terms are parts of an algebraic expression joined by addition or subtraction signs. In negative 3x plus y, both negative 3x and y are terms. Each term gets its own row or column in the model. How many terms are in the expression 4x plus 5yz? That is two terms, 1, 2. Okay, the terms are separated by a plus or a minus. How many terms are in the expression negative 4wx? Well, there's only one term there because I just have multiplication there. How many terms in the expression 2b plus c minus d? Okay, here's 1, 2, 3 terms. Again, the positive and the negative separate terms. How many terms are in A minus 6? That would be 2 terms, 1, 2. So each term would have a different row or a different column. Use the area model to multiply. There are 6 terms in this product, okay? So we have A and negative 6, 2B, C, and negative D, okay? So this was a 2 term, and this was a 3 term, and this is an A, not a 9. Okay, so A times 2B is 2AB. A times C is AC. A times negative D is negative AD. Negative 6 times 2B is negative 12B. Negative 6 times C is negative 6C. Negative 6 times negative D is a positive 6D. Okay, so I'm just going to start here and write them across. So I got 2AB. And again, you can kind of look through here. I don't have any other ABs. So plus AC minus AD minus 12B minus BC plus 6D. So I have 1, 2, 3, 4, 5, 6 terms in that. Okay, here's a vocab word of like terms. Terms that are alike except for their coefficients, which means the letters are the same, but the numbers might not be, can be combined. You've seen this idea before. If you have 10 pieces that are all XY, then you can combine those terms. So we saw this in the previous lesson. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes that are all XYs. So I have a 10XY there. Notice how the like terms are all the same shape with the same area, like the individual little yellow X by 1 rectangles in this image. So this is an exact area model. Okay, they've we don't know the length of X, so we can't really split that up into individuals, but we know that this is 3 and this is 4. So we've kind of got the model set up here. These are actually called algebra tiles that they've used here. So I've got an X squared here, and I've got 4X and 3X. Well, total there are 1, 2, 3, 4, 5, 6, 7 X terms plus 12. And this is the algebra that we're going towards, moving to. Circle all the expressions that can be combined into one term. Write the combined term underneath. Okay, so these are both X's. So we have 5, 6, 7, 8X. Okay, so we got to circle the expression and then write it. Okay, these are 2 W's, so we can combine that. So 7 W's, and if I take away 2 of the W's, I'm left with 5 of the W's. This has X and W, so no W and W. Okay, so 2 take away 7 would be minus 5W. You still need the W on there because, like I said before, the W is just the label. So this is X and nothing, 6 and X, I can't, X and X. So 6 X's plus 1X, remember there's a 1 in front of that, would be 7X. XY, XY. Okay, I can combine these. And even if this was XY and this was YX, okay, if they were switched around, those are the same. So I can combine those. So 5 minus 1 is 4XY. X, Y, and X, no. X and or Z and Y, I can't. Okay, so those are all the ones with the like terms. Ben used an area model to multiply 4 plus X times Y plus 7, but he made a mistake. Okay, let's see here. He did 4X right here. Okay, and then 7. Okay, so here it looks like he had the multiplication instead of the addition. So he put 4X on one line, which is multiplying. It should be 4 on one line and X on one line. You got to separate those. Draw an area model to find the correct product. Okay, so we've got 4x and y 7. I kind of draw mine upside down here, and that's okay. It's the exact same thing. So we've got x times y is xy. 4 times y is 4y. 4 times 7 is 28. And 7 times x is 7x. So we've got xy plus 4y plus 7x plus 28. Okay, and he missed a lot of those terms, okay, because he didn't do the addition part. He just did multiplication. All right, that's going to do it for this first lesson. On page 29, you have your additional problems that you can start working through. Combined quite a few different sets here. Okay, so page 29, you can start working, set a goal of getting halfway through that. And then in the next lesson, we'll pick up page 27 and 28. If you have any questions, feel free to reach out. I'll see you in the next lesson.